Started. We're talking about the graph of a radical function, the square root of x to be specific, and what that looks like. There are some graphing problems on 9 through 16, so we'll have to pass that out a little bit. Have a seat. Luke, why don't you grab a stack and take one and pass it down.
Absolutely. Is this hard to chew?
That doesn't look like water there, AJ. Okay, that's probably going to have to be an agglomerates. Okay, anyways, let's talk about this. So if I don't know what the graph looks like, how do I figure out what the graph looks like? We've done this a few times before. Any ideas? If I've never seen this graph before, how can I get a picture of what it looks like? Okay, you make up some x values, plug them in, and see what comes out, right? Just plug some x values in, see what y values go with them, and then graph those. So, square root of x, what happens if I plug in like a negative, like say -1? What's the square root of -1? You guys remember this? Hey guys?
It's no solution.
It's no solution. Well, we called it no real solution way back. This was like lesson 1 in this chapter. Square root of -1 doesn't really work. So you can't really do that. How about what's the square root if I plug in 0 for x? What's the square root of 0? What times what equals 0? 0. Okay, what's the square root of 1? 1. Okay, how about the square root of 2? It would be square root of 2, which is a messy value. It's about 1.4. Okay, so it's actually easier to use numbers that actually have nice square roots. So what's the next number that has a nice square root? 4. Square root of 4 is 2. 9 is 3. So if I try and graph this, the first one I could graph is 0, 0, 1, 1. I guess we could graph this 2, 1.4. Mostly I'm going to be skipping the decimals today. Just makes it easier to graph. 4, 2, 9, 3. 5, 6, 7, 8, 9. Alright, can you guys tell what shape it is? Well, it's like a hill, but it's like sloping. It's getting shallower and shallower. It's going up slower and slower. Another way you could think of it is kind of like half a parabola turned over. You guys remember parabolas? It's like this half the parabola turned over. Anyway, that's what it looks like. So, what's going on over here? Nothing. Because we cannot plug in negative x values to square root of x. It doesn't really work. So,
I just asked that.
yeah, well, we're not graphing number 1, so we can use this actually kind of number 9. So on number 1 it says determine the domain. The domain is the x values. So what x values are we using for this graph? What's the smallest x value we're using? 0, right here. We couldn't use -1, didn't work, so we had to start at 0. So all the x values above 0, are they going to work? Yes. Because everything above 0 has square root of a million, a billion, a trillion. Yeah, that's all fine. It doesn't have to come out pretty. Some of them are most of them are decimals, but it does all work. So the domain for number 1 is x is 0 included? Yes. X is greater than or equal to 0. You didn't have to graph that, but actually number 9.
May I have your attention, please? This is a storm drill. I did not want to brag on your shirt.
40.
Oh, got about 2/3 of the class. I did not stop the video.
Well, they probably heard those.
Yeah, they might have heard it. I don't think the mic is very good, like going that way, but
I heard that ding, and I'm like, not again. No.
missing like 6, 7, 8, 3.
But they're actually loads right now and it's coming right outside.
We walk slowly.
You guys got out fast.
Yeah, because like, we were like, when they walked out, and then he was like,
Bro, we would have all died if that actually happened. They didn't let us in.
That is a horrible situation. I like
They all left us. They all left
oh,
the
at least we
office.
would have all died together.
I didn't like that.
It would have been more efficient.
Yeah, there was a kid under the seat.
All the X values.
He doesn't know them.
I now do. I do now. Who?
You
Where's Josiah? Brian.
No.
Brian's with Josiah.
No, who you got?
And this is for sure.
Okay.
The grades just get like ripped off.
All right, number 3. So you don't really have to graph these to figure out what their domain is. The trick is, all right, number 3 says y equals square root of x minus 3. Okay, or minus 2. All you do, the only thing that x cannot be is whatever makes under the square root negative. So you just take what, is everybody listening? Please listen. So I don't have to explain this 1,000 times. You take whatever is under the square root, in this case it's just x, and it has to be greater than or equal to 0. Underneath the square root cannot be negative, right? So in this case, it's the same thing. The x values can be greater than or equal to 0. Now what happens though if I change it to like this? Well, in this case, x minus 2 needs to be greater than or equal to 0 because this needs to be not negative. Cannot have a square root of a negative, doesn't work. Okay, so we need x minus 2, this is how you set it up. We need whatever's under the square root to be greater than or equal to 0. Then how do I solve this for x? Plus 2. And in that case, the answer would be x could be anything greater than or equal to 2. Because if x were 2, this would be 0, and that would be okay. If x were 3 or 4, that's fine. But x could not be like 1, because this would be negative. So you just take whatever's under the square root, make it greater than or equal to 0, and then solve for x. Okay, now, that's not what number 3 said. Number 3 said this. So what's under the square root is just x. So the answer, again, is just x needs to be greater than or equal to 0.
This is pretty simple. Well, if it's an addition problem.
You just jinxed yourself.
What do you mean?
You do the same thing.
Okay. Yeah, dude.
so number 5 is kind of what I was just talking about. Is square root of x minus 5. So, but it's all under the square root. So we need x minus 5. Where's the graph paper at? That stopped somewhere.
Over here.
Okay, did the back row get any graph paper?
Yeah.
Okay. So we need x minus 5 to be greater than or equal to 0 because it's all under the square root. How do I solve this for x? How do I get rid of a minus 5 plus 5? This is basic. So in this case, x would need to be greater than or equal to 5. Okay, number 7, x plus 2 minus 3. All right, in this case, what do we need?
Plus 2 is greater than or equal to 0.
Exactly, x plus 2 needs to be greater than or equal to 0. Cannot be negative. Yep.
So why is number 3 x? Sorry, never mind. This from first. Okay.
Number 3, I made up an example to explain different kind of problem, but the original answer is just x is greater than or equal to 0. Because under the square root has to be not negative. So if there's just an x under there, it needs to be greater than or equal to 0. So what do I do to solve? So in this case, x can be anything greater than or equal to negative 2. Now, does that minus 3 affect this part? No. It's going to move the graph down. Some of you might have known that. The minus 3 will move the graph down. But it does not affect the domain. Even though the graph would move down 3 and left 2, it would look like this, but the domain is just x values that are negative 2 or above. That's the domain. All right. By the way, so how does this, we're going to do this later, how does this plus 2 move a graph when it's directly on the x? You guys remember from other stuff? No, not up 2. It's left 2, down 3. So we've done stuff like absolute value problems, like that, where this is left 2 and down 3. And we've done parabolas, like this. This makes it move left 2 and down 3. So whatever's directly on the x moves it in the x direction, left and right. But it does the opposite. So this is like negative 2, like left 2, down 3. And this, the other number moves it up or down. Anyway, getting off track here. Number 9. Make a table and a graph. I kind of already did number 1, but I'm going to do it again. Or number 9. Y equals square root of x. So what table did I make? Well, I want you guys to use like 4 numbers. So what numbers would go well in here? What numbers have nice square roots? 0, 4, what's between 0 and 4 that has a nice square root? 2 does not have a nice square root. 1, 4, and 9. So this is the square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. So these work nicely. Do you have to use these? No. But it's easier when you plug it in. Also, when you make your graphs, because we kind of know what it's going to look like, right? You just can kind of focus on the first quadrant. Like that, so you don't have to use a ton of space. Okay, if I plug in 0 for x, I get y equals square root of 0, which is 0. If I plug in 1, square root of 1 is 1. If I plug in 4, square root of 4. If I plug in 9, square root of 9. And graph those 4 points. Okay, number 11. Let's see, I can come back. Y equals square root of x minus 2. You have to wait till the end. Okay. What numbers could I plug in here? Well, the square root part is just an x. So I'm going to use the same number, just like number 9. I'm still going to use 0, 1, 4, 9. Because those have nice square roots. You don't have to use these numbers. It's just the easiest ones to use. Square root of 0 is 0, but then you have to subtract 2 on these, so it's negative 2. Square root of 1 is 1 minus 2. Square root of 4 is 2 minus 2. Square root of 9 is 3 minus 2. How is this minus 2? What's it going to do to the graph?
Move it down.
Move it down 2. So when I go to make my little graph, I should make sure it's going to be down 2, so I need to make sure and put a little bit of graph underneath the x-axis. So 0, negative 2. 1, negative 1, 4, 0, and 1. A little too sharp. Oh well. All right, on 13, I just realized 1 through 8 is the same as 9 through 16. On 13, what is that minus 5 going to do to the graph? It's going to move it right 5. It's going to move the graph right 5. Remember on number 7 how I said that moves it left 2 and down 3? So number 5, the minus 5 on the x moves it right 5. So it gets a little tricky on some of these, trying to figure out what x values might be good to plug in. Now, basically, we want the number under the square root to be like 0, 1, 4, or 9, because those have nice square roots. If you have trouble figuring this part out, I guess you could just make up some different numbers and get some decimals and graph those. But what value could I plug in for x that would make the square root equal 0? What value could I plug in for x that would make the square root equal 0? 5. So instead of, like, I can't plug in 0 here, because 0 minus 5 is negative 5. You can't have the square root of negative. So the lowest thing I can plug in, what we put on number 5, is 5. Okay, what could I plug in to make what's under the square root equal 1? 6, because 6 minus 5 is 1. What could I plug in that's under the square, that would make what's under the square root equal to 4? 9. 9 minus 5 is 4. And what could I plug in to make what's under the square root equal 9, I guess? 14. Okay, these will work out nicely because they make what's under the square root. So, for example, if I plug in 5, I get 5 minus 5 is 0, and the square root of 0 is 0. If I plug in 6, 6 minus 5 is 1, the square root of 1 is 1. If I plug in 9 minus 5 is 4, the square root of 4, 2. If I plug in 14 minus 5 is 9, square root of 9, 3. So this is going all the way out to 14. So we need to make our, oh, ugly. Focus, I gotta focus. That's good enough. Alright. To make my x-axis really long. Starts at 5, 0, 1, 2. Alright. This will be our last odd graph. Only 9 through 16 is graphing. Let's see. Plus 2 minus 3. Alright, so we want what's under the square root to be 0, because 0 has a nice square root. So what x value could I plug in right here to make this a 0? Negative 2. What x value could I plug in right here to make this equal 1? Because 1 has a nice square root. 2 plus what equals 1? Negative 1. What could I plug in right here to make this equal 4? 2. And what could I plug in right here to make this equal 9? 7. So those will come out nicely. I plug in negative 2, plus 2 is 0, square root of 0 is 0, minus 3 is negative 3. If I plug in negative 1, plus 2 is 1. Square root of 1 is 1 minus 3. Negative 2. 2 plus 2 is 4. Square root of 4 is 2 minus 3. It's kind of a, when you choose the numbers like this, there's kind of a pattern over here. Because we're choosing special numbers, so it kind of works out nicely. 7 plus 2 is not 9. Square root of 9 is 3. Minus 3, 0. So this is actually mostly below the x-axis. Because this graph is moving left 2, down 3. So that's where it starts. 2, negative 1, 7, 0. Can never get it quite perfect. Cannot be done. Starts out going up quickly and then it goes up slower and slower and slower. Okay. So yeah, really all you need is this table and then you can just graph those points. You know the picture should, what the picture should look like. 17. Okay, this is matching. Oh, I just remembered one of these we hadn't talked about. Well, two of them we haven't talked about. 20 and 21. Okay, but 17 is square root of x, which we've already like looked at that graph twice. So A, B, C, D, E, F. Which of those would be the graph of square root of x, like the basic A? Starts at 0, 0, and then it kind of goes up after that. Okay, 19. What is that plus 2 going to do to the graph? How's that going to move the graph? Left 2. Okay, 18 is up 2, but 19 is left 2. So which graph is moving left 2? D. Okay, I never talked about 20, so let's talk about 21 first, actually. We'll come back and look at 20. When you put a negative on the whole thing, what's that going to do to the graph? Any guesses? I think we've done stuff like it flips it upside down. So 21 is upside down, so what looks like E, I guess, for 21. Okay, for 20, they put the negative directly on the x. So what that's going to do is it's going to reverse the x values. So x values are like going left and right. So if you reverse the x values, like what was positive 1 will be at negative 1. So it's just instead of upside down, it's a horizontal flip. So it just makes it go backwards. Makes the x values opposite. So which one is that? C. Okay, 23. So we got to write our own function. They use the f of x equals okay. So 23 says we want it to move up 1. So how do we make the graph move up 1? Yeah.
Go square root of x, and then outside of it plus 1.
Right. Let's put a plus 1 out there. Let's see. Yeah, that moves the graph up 1. Let's make up some. Okay, again, this is kind of stuff that we've learned before when we graph parabolas and absolute value stuff. Okay, what does a plus 1 directly on the x do to the graph?
Make it go left 1.
Right, it's left 1. So that means this would be right 3. Okay, what's the plus 2 out here do?
2.
Up 2. So that means this is down 4. Okay, that's the pattern we've learned in the past. It works on everything, really. When it's directly on the x, it affects the x motion, but it does the opposite of what it says. So plus 1 actually moves left 1. Minus 3 moves right 3. The other number out off to the side moves it up and down, kind of like you might guess, so it's up 2 or down 4. Okay. Anyways, back to this. 25, almost done. We need to make it move 2 right and 2 down. So how do I make it move 2 to the right? Luke?
Square root of x minus 2.
Okay, minus 2 inside.
Outside minus 2.
And 2 down is minus 2 outside, yeah. 2 right, 2 down. Reflected across the y-axis. We kind of just talked about this. Which one is the y-axis?
The up and down.
This one, yeah. So how do we reflect it? We talked about this a couple minutes ago. How do we reflect it over.
Even,
Yeah, you put a negative in front directly on the X, like number 20, I think it was. Yeah, so it's number 20 basically. So after you do the graph part, it should go pretty quick, pretty fast after that.